Neutral to ground swells in the range of 100 volts are not typically a concern for line isolation monitor systems. In line isolation monitor systems, the neutral conductor is isolated from ground, so neutral to ground voltage readings do not directly indicate the integrity of the grounding system. However, prolonged neutral to ground swells above 100 volts may indicate a potential fault condition or degraded equipment. Transient voltage levels up to 1400 volts can be a concern, especially if they occur frequently. These transients can be caused by motor loads or other non-linear loads that generate harmonics. High transient levels can damage sensitive electrical equipment and cause electromagnetic interference. It is recommended to monitor the neutral to ground voltage levels over time to track any trends or changes. Investigate the source of the transients and implement mitigation measures, such as installing transient suppression devices or redesigning load circuits. Consider performing a comprehensive power quality survey to assess the overall electrical environment and identify potential issues. It is important to note that while line isolation monitor systems provide electrical isolation, they do not eliminate all power quality issues. Maintaining proper grounding and power distribution practices is still essential for ensuring the safety and reliability of surgical equipment. To further elaborate on the neutral to ground swells, it's crucial to understand the context of an isolated power system like those used with line isolation monitor systems. In a standard grounded electrical system, the neutral conductor is bonded to ground at the service entrance. This creates a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protection devices like circuit breakers. However, in a line isolation monitor system, the neutral is intentionally isolated from ground. This is done to limit the potential for leakage current to flow to ground, which is particularly important in sensitive areas like operating rooms where even small currents can pose a risk to patients. Because the neutral is isolated, a voltage difference can exist between the neutral conductor and ground without necessarily indicating a ground fault condition. This voltage difference is often due to capacitive coupling between the isolated conductors and the grounded enclosure or other grounded objects. The level of this voltage depends on several factors, including the length of the conductors, the frequency of the power supply, and the impedance of the isolation transformer. A reading of around 60 volts between hot to ground and neutral to ground is fairly typical in a properly functioning line isolation monitor system. The neutral to ground voltage will likely fluctuate somewhat depending on the load distribution and the characteristics of the isolation transformer. A significant and sustained increase in the neutral to ground voltage above 100 volts could suggest an issue, but it's not automatically indicative of a dangerous ground fault. One possibility is that the isolation transformer is developing a fault, such as a breakdown in the insulation between the primary and secondary windings. Another possibility is that there is excessive leakage current flowing from the isolated circuit to ground through some other path. This could be due to damaged equipment or improper wiring practices. To properly diagnose the cause of a high neutral to ground voltage in a line isolation monitor system, it's important to use a high impedance voltmeter to avoid loading the circuit and affecting the readings. It's also helpful to measure the voltage between each isolated conductor and ground to see if the problem is isolated to one particular leg of the system. Furthermore, the line isolation monitor itself should be checked to ensure that it is functioning correctly and not generating false alarms. Turning now to the transient voltage levels, these are short-duration voltage spikes that can occur on an electrical system due to a variety of causes. Motor loads are a common source of transients, particularly when they are switched on or off. The rapid change in current flow can induce voltage spikes in the surrounding circuitry. Other nonlinear loads, such as electronic devices with switching power supplies, can also generate harmonics and transients that can propagate through the electrical system. Transients can be problematic because they can damage sensitive electronic equipment. The high voltage spikes can stress the insulation of components, leading to premature failure. Transients can also disrupt the operation of digital circuits and cause data errors. The severity of the transient problem depends on the amplitude, duration, and frequency of the transients. Transients with amplitudes of 1400 volts can certainly be damaging, especially if they occur frequently. To mitigate transient voltage levels, several strategies can be employed. Firstly, transient voltage surge suppressors can be installed at various points in the electrical system to absorb or divert the transient energy. These devices typically use metal oxide varistors or silicon avalanche diodes to clamp the voltage to a safe level. Secondly, line reactors can be used to reduce the rate of change of current flow when motor loads are switched. This helps to dampen the voltage spikes that are generated. Thirdly, harmonic filters can be installed to reduce the levels of harmonic currents produced by nonlinear loads. These filters typically consist of capacitors and inductors that are tuned to specific harmonic frequencies. In addition to these mitigation measures, it's also important to ensure that the electrical system is properly grounded. A good grounding system provides a low impedance path for transient currents to flow to ground, which helps to reduce the voltage stress on sensitive equipment. Finally, it's essential to conduct a comprehensive power quality survey to assess the overall electrical environment and identify any other potential issues. A power quality survey involves measuring various electrical parameters, such as voltage, current, frequency, harmonics, and transients, over a period of time. The data collected during the survey can be analyzed to identify the sources of power quality problems and to develop effective solutions. To summarize, when dealing with suspected power quality issues in a surgical environment with a line isolation monitor system, it's important to carefully analyze both the neutral to ground voltage levels and the transient voltage levels. While neutral to ground swells of around 100 volts may not be immediately alarming, they should be monitored closely to detect any trends or changes. Transient voltage levels of up to 1400 volts can be problematic and should be addressed through appropriate mitigation measures. A comprehensive power quality survey is recommended to assess the overall electrical environment and identify any potential issues. Remember that maintaining proper grounding and power distribution practices is crucial for ensuring the safety and reliability of surgical equipment, even in systems with line isolation monitors. Further consideration should be made as well. Firstly, regularly inspect and test the line isolation monitor itself. Ensure it's functioning according to manufacturer specifications. This includes verifying the alarm thresholds and response times. Secondly, document all power quality measurements. Keep a detailed log of neutral to ground voltages, transient levels, and any other relevant data. This historical data can be invaluable for identifying trends and diagnosing problems. Thirdly, consider the impact of new equipment. When adding or replacing equipment in the surgical environment, assess its potential impact on power quality. Nonlinear loads, in particular, can introduce harmonics and transients into the system. Fourthly, train staff on power quality awareness. Ensure that personnel working in the surgical environment are aware of the potential impact of power quality issues on equipment performance and patient safety. Fifthly, engage with qualified professionals. When dealing with complex power quality problems, don't hesitate to consult with experienced electrical engineers or power quality specialists. They can provide expert advice and assistance in diagnosing and resolving issues. Sixthly, prioritize patient safety. Always prioritize patient safety when addressing power quality concerns in a surgical environment. If there is any doubt about the safety or reliability of the electrical system, take immediate steps to mitigate the risk. Seventhly, review relevant standards and guidelines. Familiarize yourself with applicable standards and guidelines related to electrical safety and power quality in healthcare facilities. These documents can provide valuable information and recommendations. Eighthly, implement preventative maintenance. Establish a preventative maintenance program for electrical equipment in the surgical environment. This can help to identify and address potential problems before they lead to power quality issues. Ninthly, consider using uninterruptible power supplies. Uninterruptible power supplies can provide backup power in the event of a power outage or voltage spike, which can be critical for maintaining the operation of sensitive surgical equipment. Tenthly, investigate grounding practices. Ensure that all equipment is properly grounded according to applicable electrical codes and standards. Poor grounding can exacerbate power quality problems and increase the risk of electrical shock.